So, in these 5 examples, we're going to transform 5 of the parent functions in using a single transformation. So we're going to begin with the absolute value function. If g of x is the absolute value of x plus 4, I can write g of x using f of x by saying g of x equal f of x plus 4. Now remember that f of x is the same as y. So here's my absolute value function. What happens if I add 4 to the y values of each of these points? Here's 0, 0. If I add 4, I get 0, 4. Here's 1, 1. If I add 4, I get 1, 5. Here's negative 1, 1. If I add 4, I get negative 1, 5. And so the result is shifting this graph up 4 units. Now, if h of x is the absolute value of x minus 3, I can do the same thing. Absolute value of x is f of x minus 3. Again, f of x is the y. If I subtract 3 from each of the y values of the point, or y coordinates of the points in the parent function, the effect is shifting the graph down 3 units. Notice that the plus 4 and the minus 3 are outside of the function. If our parameter is outside of the function, then it affects the y's. Now we're going to go to the next example. Here we have y equal 1 over x, the reciprocal function. Remember, to graph the reciprocal function, we use the points 1, 1 and negative 1, negative 1, and the x and y axis as the asymptotes. Now look what happens if I write g of x, 1 over x minus 3, using f. What is in place of x? X minus 3. So this is g of x minus 3. Notice the difference here is now the minus 3 is in the argument of the function. If it's in the argument, it's not going to affect the y's, it's going to affect the x's. What value of x would make this 0? 3. So when x is 3, this function is undefined and there is a vertical asymptote. Notice when x is 4, 1 over 4 minus 3 is 1. When x is 2, 1 over 2 minus 3 is negative 1. So the minus 3 in the argument shifts this graph 3 units to the right. If the parameter is in the argument, it affects the x's, and if it affects the x's, it's always the opposite of what you see. So if we move over to h of x, this would be, whoops, and I made a mistake. This should be f, not g, of x minus 3. This is f of x plus 4. So I'm going to shift the opposite of what you see. So if you see plus 4, we're going to go to the left 4. Negative 4 would make this function undefined. 1, 1 goes to negative 3, 1. And negative 1 goes to negative 5, negative 1. Any questions? I'm going to go back here and make sure I didn't make a mistake on the first one. No, I wrote those using F. All right. Now let's go to the third example. The square root function. 0, 0, 1, 1, 4, 2. If g of x is negative square root of x, this negative is on the outside. If it's on the outside, it affects the y's. If I put in 0, I still get 0, but instead of 1, 1, I would get 1, negative 1. Instead of 4, 2, I would get 4, negative 2. So the blue graph, a negative on the outside, changes the sign of the y's, so it reflects it over the x-axis. Now let's look at what happens when the negative's in the argument. This would be f of negative x. If it's in the argument, it should affect the x's. If the x's change sign, it's going to have to reflect over the y. Let's think for a minute what the domain of this function is. If negative x is greater than or equal to 0, then x has to be less than or equal to 0. If you put in a negative 1, you get 1. You put in negative 4, you get 2. So a negative in the argument is a reflection over the y-axis. Outside, reflect over the x, the y's are affected. Inside the argument, reflect over the y, the x's are affected. Next example, y equals x squared. If g of x is 2x squared, then this is 2 times f of x. F of x is y. What happens when we multiply the y's by 2? 0, 0 stays 0, 0. But 1, 1 becomes 1, 2. 2, 4 becomes 2, 8. Negative 1, 1 becomes negative 1, 2. Negative 2, 4 becomes negative 2, 8. The effect on the graph, as you learned in Algebra 1 and Algebra 2, is that this is a skinnier parabola because a is greater than 1. But I want you to think of this as a vertical stretch. A vertical stretch. H of x is 1/4 x squared. Well, I know I can multiply the y's by 1/4. That makes this a vertical compression. But I'm going to do this a little differently. Notice that this is 1/2 x squared. So this is f of 1/2 x. Now, I've got these points here. I know that I've got a point 416 on the parent function, so that means if I multiply y by 1/4, it would go through, 4, 4. So, I know the graph of h looks like this. Now, this is a vertical compression, and and I'm going to introduce BAFO. Stands for by a factor of 1/4. Or it got wider, didn't it? By what factor did it get wider? 1 became 2, 2 became 4. It's a horizontal stretch by a factor of 2. It's the opposite of what you see. We didn't multiply the x's by 2. We multiplied the x's by 1/2. We multiplied the x's by 2, which is the same thing as dividing the x's by 1/2. Multiplied the x's by 2. All right, the last example is the greatest integer function. To review, when we plot the greatest integer function, we plot the point 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and then between 0 and 1, it's 0, between 1 and 2, and that pattern, it's 1, and that pattern continues for the negatives as well. Steps 1 unit long, solid dots on the left, open circles on the right. Now, if the 2 is outside, this is 2 times f of x. We multiply the y's by 2. This is a vertical stretch by a factor of 2. So, if y is 0 and I multiply y by 2, it stays 0. If y is 1 and I multiply it by 2, it goes to 2. If y is 2 and I multiply by 2, it goes to 4. What's happening? These steps are not 1 unit apart. These steps are now 2 units apart. See that? -2 would go to -4. And -3 would go to -6. And -4 is not on there. So, I spread the steps out. Now, if it's in the argument, like the greatest integer of 2x, this would be f of 2x. Now, let's use our logic. It's in the argument, so it affects the x's. So, I'm going to start with horizontal. If it's in the argument, it's always the opposite of what you see. So, if I say times 2, instead it's going to be by a factor of 1/2. So I'm going to divide the x's by 2. That means it's going to be a compression. So, x's, these steps are now just going to be a half a unit long. Let's check that. What happens if I put a half in here? 1/2 times 2 is 1, and the greatest integer of 1 is 1. What is 2? What is 1? Then that's the greatest integer of 2, which jumps up to 2. So, these steps are now just a half a unit long. Put in -1/2, that's -1. Put in -1, that's -2. I understand that it's a little bit confusing when you see it on top of each other, like this. But the steps are just a half a unit long, and they're still 1 apart. Hope this helps. We'll do group work in class tomorrow. Have a good evening.